or surface area.
The main topics we're going to cover today are the definition of surface area and how we calculate surface area.
Wait, sorry, I couldn't hear you like at all.
Can you hear me now?
Yeah, it's better now.
Okay, so the main topics we're going to be learning today are the definition of surface area and how we calculate surface area. So what is surface area? Surface area is the area outside of a 3D object. So let's look at area first. You already know what area is. Area is the inside of a closed 2D object, or it's the amount of space, 2D space a 2D object occupies. And the surface area is the area of the outside of a 3D object. It's the sum of the areas of all the faces or surfaces on a 3D shape. So for example, the surface area of a cube is the area of all 6 faces of the cube added together. So how do we calculate surface area? First, we must find which 2D shapes make up the surfaces of the figure. We have to see how many faces, and next we have to calculate the area of each 2D shape. Each face, we have to find the area. And then we have to add the areas together. So how many other faces there are, we have to multiply the area of each face times that number. But keep in mind that some shapes have a specific formula that makes it easier to solve for the area, such as cones and spheres. But for this example, what is the surface area of this cube if A equals 12? So if the length equals 12, then we know the width and height also equals 12. So a square is a 2D shape that makes up the surface, like we just said. So the area of each of the squares of each of the faces would be length times width, which is 12 times 12, 12 squared, which is 144 units squared. Okay, and then a cube has 6 faces, so we can add up 144 6 times, or 144 square units times 6, and we get 864 units squared. That is the surface area of this cube. Let's try a few practice questions. So our first example is a rectangular prism. You can see the dimensions right here. So you can try to figure this out on your own, and then we can go over it together. But yeah, go ahead and try it out yourself.
Okay, yeah, that's right, Avery. 164 inches squared. Don't forget the units.
Okay. Yeah, so we can go over the steps, how you should have done it. So the shapes of the faces are all rectangles, as you can see. So because we're given the dimensions, this longer, bigger face, the area is 4 times 10 inches. And then this smaller face is 4 times 3. So the face shape 1 is 3 times 4, which is 12 inches squared. And we know that there are 2 such faces, 2 faces like this. So there's one here, and it's not really visible, but it's on the other side. It's exactly on the opposite side of the rectangular prism. And then so we multiply that by 2. And then face shape number 2 is 4 times 10. Okay, 4 times 10, and we get 40 inches, and there's 2 of these. We know that there's 2 of these. There's one like here facing us, and then there's one directly opposite on the opposite side of the rectangle. And then face shape 3 is 3 times 10, this 3 times 10. And when we multiply that, we get 30, and then we know that there are 2 of them. So the surface area of this, like we said earlier, like you calculated correctly, would be 2 times 12 plus 2 times 40 plus 3 times 30, which is 164 inches squared. And remember, the units for surface area are the same as regular area, which is units squared.
Okay, Avery, I saw your message. No worries. Okay, so this one is a pyramid. And it has a special formula for the surface area. You see, it's complicated at first, but we realize we have all of these. We're given L, W, and H. So in reality, even though this looks complicated, we can just plug it in. Yeah, of course, LW represents the base of it, and these two added up represents the 4 sides. So yeah, this one already has the work shown, but I'll lead you through it. So length times width of the base at 6 times 12, and then length, plug in 12 here. H, we can plug in 10 as height. Width is 6, so 6 divided by 2 here, which is 3. And then we have the width here, which is 6, so we can plug it in. We have the H, which stays the same, so it's also 10. And we have L over 2, which is length over 2. We square it. So yeah, just look at these steps, and I don't think there's actually that much of a need to memorize it, but it's just good to know. So here it is. Oh yeah, also like for different types of pyramids, like the area would be the surface area would be different. Like for example, if it's a triangular pyramid and the base was a triangle, the formula would be different. Okay, so let's look at the formula for this cylinder. So it's 2 pi r squared plus 2 pi r height. So yeah, we know this because one of the circles, the formula is pi r squared, right? And then we have 2 of the circles, so that's 2 pi r squared. So one circle, and then the surface area of the like kind of the length of the pyramid where it wraps around, that's represented by 2 pi r times height. So we know that radius is 9 inches and height is 20 inches. So for surface area, we can plug in the numbers. So radius is 9, we can plug it in. And the height's 20, we can also plug that in. And then we can just add them together and multiply pi out as 3.14. And then we can get 1,639.91 inches squared. Okay, so the formula for this cone, we can see it's kind of similar to a cylinder. We know that the pi r squared, that's the circle, but there's only one circle this time, so it's just pi r squared. And then the part that wraps around, that's pi r times length, and length is the length of the diagonal. So not the height or not the radius, but this length, which is 100. So we're given the diameter actually, which is 44 inches. So we can divide by 2 in order to find the radius. And the length is given as 100 inches. So we can multiply these out. We do pi times 22 times 100 plus pi times 22 squared equals 8,432.03 inches squared. Okay, so let's review here. Surface area is the area of the surface of a 3D object. So that's the part where you can where it's exposed to the outside. And there are multiple steps to find a surface area. You can find the 2D shapes that make up the 3D shape. For example, the rectangular prism. and then you can find the area of all the rectangles and add them together. Yeah, which is that. Or you can use specific formula for more complex shapes like pyramids or cones. Okay, I'm gonna stop recording.